Saxon's Trig, Lesson 10, Equation of a Line, Rational Denominators, and Completing the Square. I'm probably going to split these into individual videos. So for this first one, let's talk about the equation of a line. So if you have a horizontal line, it has a slope of 0 because a slope stands for how much does it slant. Technically, slope is rise over run, and you probably heard that in your Algebra 2 class quite a bit. But because this one does not have any sort of a slant, it has a slope of 0. If you have a vertical line, it has an undefined slope. I can't count rising and running when I'm going this way. So we call it, well, to be precise, you have rise, but you have run of 0. And if you're talking about a slope being rise over run, your run can't have a 0 in the denominator. So that makes it undefined. All right, then it goes into how do we find the equation of a line? And there are multiple formats, but the one they want to focus on is called the slope-intercept form. Oops, sorry, that word got kind of split there. All right, but basically it is looking for the equation y equals mx plus b. This is your slope-intercept. Intercept is where you cross the y line, and that is your b. B is considered your intercept. M is the letter considered for slope, and then the y and the x are standing for in the 4-quadrant grid or Cartesian plane, however you've been taught it. This is your x line and this is your y line, and so they are the letters that remain in the format for slope-intercept form. So as we begin to talk about this equation that we want to fill into, let's talk about the slope first. And I've already given you that slope stands for rise over run. And you always picture coming from the left-hand side of the graph, moving to the right. And they find it easy to show you picturing mentally a car. So if coming from the left, your car has to drive up a hill, if it looks like this, then it is a positive slope. If your car coming from the left rolls down the hill, your slope will be negative. So that is how, looking at a picture, you will know whether you are filling in a positive or a negative for your M. Once again, your B is the intercept. It is the number where you cross the Y line, never the X line. The intercept is Y-intercept, and so that is usually where you begin your count from. So if you're given a picture and you're asked to write it in slope-intercept form, you're going to begin by pulling the B number, and then from there, you're going to count the rise over run and fill that in, and then use the direction that the car was going to fill in, whether it was positive or negative. All right, so in example 1 on page 75, they give you a graph, but they do not show you the grid line behind. So they show some tick marks to indicate 1, 2, 3, or whatever it's going to be, but they don't fill in all of the lines to form the background grid. So this makes it a little harder to sometimes see where your next spot is that you should actually be counting to for your rise and run. But for some reason, this gives students fits. So when you are seeing all of the background grid lines, and this being your main ones, I'll put some arrows on it that'll help so you can tell from the background lines to the actual X line and Y line. So if I start a dot here and I'm putting a line through that I'm trying to label, this one does not hit in the crosshairs of the background grid mark. It's in between them. This one, however, was meant to show going right through that grid line. So it is an acceptable second dot to pull. This one's a little below it. Again, it's kind of bleeding close together to that line, but I was trying to show that it was below and not actually hitting in the crosshairs of the background grid. These two are acceptable places to count rise and run because they're crossing the grid marks exactly in the corners. Okay, so in example 1, they don't give me the background grid marks, but usually I can tell. I just need to be careful. So it says, find the slope-intercept form of the equation of the line that passes through the point -3, 2, and 4, -3. Now, one of the reasons why the grid mark isn't here is because you're going to draw that graph yourself and label those 2 dots. You're not going to bother to put all those grid marks in the background. You can choose, if this really gives you fits, to get graph paper and to do all of these on graph paper itself. I feel like you can probably handle it without the graph paper, but that's totally up to you. So we are going to put the dots -3, 2. So my first number is always the x number. That's going on the x-axis. This one's the y. Let me go ahead and put some tick marks here so I have things to count. And I try, so that my grid will work well, to space them evenly. That's where the graph paper can be very helpful. All right, so it was -3, so I start at 0 and I go backwards 3, but I don't put my dot there. I must have my second number so that I know where to put the other dot, which was 2, so I climb up 2, so -3 up 2, and I can put the dot there. The next one was 4, -3. So I go back to 0, 0, 4 on the x-axis, and then down 3 for this one. So the line that I'm drawing, this is what I'm trying to find the answer for in the format y equals mx plus b. So I know I'm going to have a y and the x. And I first want to begin with the b. Where did I... if I can, where did I cross it? No, it's not even enough. It's not right at 0, 0. It's just below it. So we're not going to do that. Let's start with our slope. So from these 2 exact dots, how much did I rise and how much did I run? Well, I can count it. 1, 2, 3, 4, 5 is my rise. Run of 1, 2, 3, 4, 5, 6, 7. The car came and rolled down the hill, so that makes it -5/7 x. Okay, I'm going to pause there for a split second. There is a formula that you can use for rise over run. I'm sure you saw it in Algebra 2. And it is for rise, because that's dealing with the y numbers, y2 minus y1, sorry, that should be subbed, y2 minus y1 over x2 minus x1, because the run is on the x, did I just say that backwards? No, correct. Run is on the x-axis, this way, rise and run. Okay, so you probably had that formula. You could take those 2 points that were given in the book and do this rather than counting them to double check yourself, or if you just prefer to do this and plug those numbers in to get the slope, however you wish to do it. All right, now that you have that, you can solve for the b, since it wasn't nice and even in the crosshairs. So to do so, you want to pull an x and a y number, one of the 2 dots that you graphed. So doesn't matter which one, I'm going to choose the first one, -3, 2. So because the -3 is the x, the 2 is the y, it's going to be 2 equals -5/7 times the -3 plus the b, and then I can solve for that. So negative times negative is positive, 15/7. We're going to move that over, going to make it 2 minus 15/7 is b. To do that, either calculator or common denominator. So the common denominator would be 7. That's going to change that to 14. 14 minus 15 is -1/7. That's the b. So for my final answer, I go back to where I was filling in here and make it the -1/7. and that is the equation for this line. Example 2, at the bottom of page 75, says find the equation of the line that passes through 2 given points and is perpendicular to this other line. Okay. So I'm going to just picture, not actually draw the graph to help me this time. I know that I would have a dot at -2, 5, so that's somewhere over in here. And I've got a line, and I don't know where that line is, but let's just say it's here. Okay, so what it's saying is find the equation of a line that goes through this point and is perpendicular. So when I draw a line through this point, through this line, it must form 90 degrees at that corner. That's the perpendicular part. So I need to know something about slopes and perpendicular lines. So if the slope of this original is a -1/2, the perpendicular slope of the new one would be flipped and negated. So positive and 2 when I flip that over. So if I find the slope of this original given line and I flip and negate it, I now have the slope of the new line, and that's what we're going to do. So they gave us 3y plus 4x equals 2. This is not in the right format for me to pull its slope. In order to pull its slope, I need y to be isolated. So 3y equals 2 minus 4x when I move it to the other side. Y needs to be alone. Divide every part by 3. So y equals 2/3 minus 4/3 x. Which one of these is the slope? Now, it's written in this order, but the slope from y equals mx plus b gives me the major reminder that the slope is always with the x. That's this one. This is the slope. So the m for this problem is -4/3. And remember, I want the perpendicular of that. So its perpendicular slope is no longer negative but positive, flipped to 3/4. So we're going to fill in to y equals mx plus b with m being 3/4. All right, we were given a point that we can use, and it was this -2, 5. So this is my x filled in here beside the m. 5 was my y filled in, and I don't know my b. I do have my slope. Now I'm going to solve for b. So 5 equals -6/4, and I can reduce that to 3/2 plus b. And then add that to this side and go ahead and give it a common denominator of 2. So that's going to turn this into 10. 10 plus 3, 13/2 is my b. So back for, it wanted the equation of the line. So y equals, my slope was 3/4 x, and my solved b was 13/2. Can you write that as a mixed number in your answer? Sure. We just tend to leave it improper in this kind of a problem, but it's okay if you don't. There's that one. Example 3, find the equation of lines A and B. This does show you the background grid, which they want to do to be extremely precise in helping you find these answers. So A is a straight line. Here's my Cartesian plane, and A is running here. So what is the equation of that line? Well, which axis did it cross? It crossed the y-axis. So we are going to state that as y equals, and at what number did it cross? -2. So there is no y equals mx plus b with this one. It is just y equals -2. And remember that we said in the other, at the beginning, that horizontal lines don't have a slope. So there is no m part in this y equals mx plus b. This is just the b part filled in. Well, where did you cross at the y-axis? At -2. So it does fit this format. It's just this part is 0 and therefore dropped off. Part B is a slanted line. And when I look, I see that the line is over in here, and so it's not touching the y-axis. I can't see exactly what my B is, and I don't want to extend it and possibly risk getting it off. So I'm not going to begin with my B, which is where I normally would. So I'm going to identify 2 places where I do cross the background grid hairs evenly, and I have to look very closely here to see, and all of them are off just slightly, including that one up there by the +4. So the only 2 I think I can guarantee for sure are the 2 dots at the beginning and the end of this picture. So what is the number up here? How far over on the x-axis and how far up on the y is that? So this one is -1 over and 6 up. Then the other one at the bottom is -6 over, and how much down? -5 down. And that's about where that crosses off the edge of the graph. When I have these 2, I can try to count their rise and run, or I can use that formula that we said. So if I try to do the formula rather than counting the grid lines, it is y2 minus y1 over x2 minus x1. So that would be -11 over, and 2 negatives make a positive. -6 plus 1 is -5. So these both cross off. So it's a rise of 11, a run of 5. Okay. And I could do the same thing by counting 11 and 5, however you wish to do that. All right, then filling into y equals mx plus b, that's my m, 11/5. Use one of these. I'm going to use this one because the numbers are less. So this is my x, multiplied by -1. Don't know the b. This is my y. And now solve for b. So this becomes -11/5, adding to the other side. So 6 plus 11/5. Need a common denominator of 5, making 30. So b is 41/5. And now fill the whole thing in for my final answer. Y equals the slope of 11/5 x, and my b, 41/5. Okay. Yep. All right. I'm going to stop here and do part B in another video.